Good day, students. I'm Miss Berguitta Labrosse from Perseverance Secondary School, and I will be teaching chemistry today. The topic today is the particulate nature of matter with the subtopic changes of states. We will go over the objectives. For today, we're going to describe the changes of state of matter in terms of melting, boiling, freezing, evaporation, condensation, and sublimation. We are also going to explain the changes in terms of the kinetic theory. Now we are all familiar with the diagram whereby we see that solid changes to liquid through melting and liquid changes to a gas through evaporation. And the same thing happens from gas changes to liquid through condensation and liquid changes to a solid through freezing. However, some of us may not be familiar that some solids, they will change directly from solid to gas without passing through the liquid phase. And this will be known as sublimation, and the reverse, whereby gases change directly to solid without passing through the liquid phase, will be known as desublimation. Now let's look at each of these processes individually. So melting is simply when a solid changes into a liquid. It requires heat energy, which is transformed into kinetic energy, which makes the particles move. We all know that particles in solids are in a fixed position and they vibrate in fixed position. Now as they gain that energy, they have enough energy now to change their arrangement and they turn into a liquid. The temperature at which a solid changes into a liquid is known as the melting point, and it is specific for each pure solid. So it is specific for each pure solid. An example, let's say we've got ice. Ice will change from solid to liquid at 0 degrees Celsius if it is pure ice. Boiling is when a liquid changes into a gas. Again, this one requires heat energy, and it happens whereby bubbles of gases form below the surface of the liquid. So now all the particles in the liquid will have enough energy for them to escape from the surface and within the liquid also, not just at the surface. Again, boiling happens at a specific temperature which is known as the boiling point, and this again is unique for each pure liquid. Example, water will boil at 100 degrees Celsius if it is pure water. However, there is another process similar to boiling which is known as evaporation. Again, evaporation changes from, is a change of state from liquid to gas. However, it does not happen at a specific temperature. It happens over a range of temperature. Let us take the example of when the rain has fallen, and then we see that over some time we've got puddles over on the roads. After some time, what will happen? We'll see that the puddles have dried up. Of course, the temperature has not reached 100 degrees Celsius. However, the liquid in the puddles, the liquid water, has evaporated into a gas. And what has happened? It has the particles at the surface of the liquid has had enough energy for it to escape as a gas. However, the particles below the surface has not had enough energy. So the difference between evaporation and boiling is that boiling will happen throughout the liquid, whereas evaporation will happen only at the surface of the liquid. So what are factors that encourages, or the factors which speed up evaporation? If you have a larger surface area, so more particles have higher energy at the surface, so evaporation will be faster. And again, if it is warmer, if the temperature is higher, so on a sunny day, the puddles will dry up faster compared to a cloudy day. Or when the day is cold, when it is colder, it will take longer for the puddles to dry compared to when it is hot. So a higher temperature, okay, will cause the evaporation to happen faster. Freezing. Now freezing is the reverse of melting. It is when a liquid changes back into a solid. To note, freezing and melting, they happen at exactly the same temperature. So water will freeze at 0 degrees Celsius as it will melt also at 0 degrees Celsius. Now, for freezing, we need to decrease the energy compared to melting, whereby we had to increase the temperature. For freezing, we have to decrease the temperature, because the particles need to lose the extra energy and now become clumped together and start to vibrate in fixed position rather than slipping and sliding over each other. Condensation. Condensation is when a gas changes into a liquid, usually upon cooling. And these gas particles, as they bump together, if the temperature is cooled and they don't get enough energy, what will happen as they bump into each other, they start to clump because they don't have enough energy for them to bounce away. So then they group together, they clump, and then they form a liquid. Now, sublimation. So sublimation, it's when a solid changes directly into a gas. It does not pass through the liquid phase. This happens not in all solids. In some solids only. Example you can give is iodine, solid iodine, and solid carbon dioxide. These two, they will change from solid and directly to gas without passing through the liquid phase. Now the reverse of sublimation, sometimes you call it sublimation, or you may call it deposition or desublimation. And sublimation happens at a specific temperature which is unique for a pure substance. So each pure substance will sublime at a specific temperature. Now, how do we explain the changes of state in using the kinetic theory? So kinetic theory, it's about kinetic energy. When substances are heated up, they absorb thermal energy, and this thermal energy is converted into kinetic energy. Reminder that thermal energy, another word for thermal energy is heat energy, and kinetic energy is movement energy. So, if you heat a solid, you heat up a solid, its particles start to vibrate more, and as the temperature increases, they vibrate more and more and more. So the solids are in a fixed position. As they vibrate, they start to vibrate so fast that they can overcome the forces of attraction that holds their structure in place. So now when they can overcome this force of attraction, therefore the structure breaks. So no longer they are in a regular pattern, no longer they are in a fixed lattice. Now they are just randomly moving over each other. And this structure is the liquid structure, whereby they just move, they slip and slide over each other. So we say that the solid has melted. Now if you keep on heating that now liquid, it is a liquid now. It has changed from solid to a liquid. So if you keep heating it up, you'll see again that the liquid particles will gain more energy. They will move faster and faster, and eventually they will overcome all the force of attraction that holds them, and they will change into a gas. They will move randomly in all directions. And this, we say that the liquid has evaporated. Please note that when the boiling temperature, when we've reached the boiling point, of the liquid, all the particles have enough energy to escape as the liquid boils. However, if it's just evaporating, not all the particles have that energy to escape. Only the surface particles in evaporation, only the surface particles have enough energy, but in boiling, all the particles within the liquid has enough energy to escape as a gas. Now the heating curves. all solids and liquids, they will evaporate, as they are heated up, the temperature and the changes of states can be displayed using a heating curve. If we look at the diagram, we'll see that the x-axis is usually, for a heating curve, the x-axis is usually heat added, so you are adding heat, and the y-axis is showing that the temperature, the increase in temperature as you add the heat. So let's take a solid below its melting point and you start heating it up. What you will see is as you keep adding the heat, the temperature will keep increasing. However, there will come a point that even if you keep adding the heat, the temperature will remain constant. You will have a plateau. This is called a plateau. It's the horizontal line that we see, and the temperature is constant. Now we say that this is where the solid is melting. The solid is melting. At this state, some of the particles are in the solid forms and some of the particles are in the liquid form. So there's an equilibrium whereby we've got both solid and liquid at the melting point. Then after some time, if you keep heating it, you keep adding the heat, after some time all the solid will have melted and everything will have been in the liquid form. So again now the temperature will increase. Temperature will increase and it will keep increasing until it reaches the boiling point. As it reaches the boiling point, all the heat energy being added will not be used to raise the temperature, but all the heat energy will be used for kinetic energy. So it will be converted into kinetic energy and the particles will move faster and escape as gas. So when we've got the second plateau we've got both liquids and gases at the same point. We've got the liquid form and the gas. Then eventually, as you keep heating it up, then all the particles will have been gas and they will be gas and the temperature will keep increasing again. Okay, so now let us see if we understand the concept. So we'll go over some questions to see if we understand. So there's question 1, it goes like this. A substance was analyzed and was found to have a boiling point of 450 degrees Celsius. At room temperature, it is a soft gray solid. Okay, so which temperature could be the melting point of a pure sample of the substance? So for these questions, you need to identify key information. The first part of the question says the substance have a boiling point of 450 degrees Celsius. So this is a key information. Boiling point of that substance is 450 degrees Celsius. Therefore, above 450 degrees Celsius, the substance is a gas, and below 400 degrees Celsius, the substance is a liquid. We need to note this. Second part, it says that at room temperature, it is a soft gray solid. In chemistry, the room temperature, we take it as 20 degrees Celsius. So we say at 20 degrees Celsius, we know that the substance is in the solid state. So now, which temperature could be the melting point of a pure substance? Please note that it says it is a pure substance. So A, answer A is negative 12. Negative 12 is below 20 degrees Celsius. So if the sample actually melted at negative 12 degrees Celsius, then at 20 degrees Celsius, the sample will not have been a solid. So answer A is incorrect. Then you've got answer B and C, which says 56 degrees Celsius to 72 degrees Celsius, and C 250 degrees Celsius to 275 degrees Celsius. These are ranges of temperature. As we said before, a pure substance will boil or will melt at a specific temperature. But B and C, they've given range of temperature. So it cannot be correct because the substance is pure. The pure sample has been taken. So we are left with answer D. Now let us see if answer D is correct. Is answer D, 142 degrees Celsius, below the boiling point? The boiling point is 450, so therefore, yes, it is below the boiling point. And is answer D above room temperature, which is 20 degrees Celsius? Yes, it is above 20 degrees Celsius. So therefore, answer D is the correct answer. Okay? Okay, so the theory question, let's go over theory question. So it says compound X is a colorless liquid at room temperature. So at 20 degrees Celsius, compound X is a liquid. So it says a sample of pure X was slowly heated from -5 degrees Celsius, which is below its melting point, to 90 degrees Celsius, which is above its boiling point. Its temperature was measured every minute and the results are represented on the graph. If we look at the graph, automatically we'll be able to identify that this is a heating curve of compound X. So the first part says, complete the equation for the equilibrium present in the region BC. So it says you see capital X, X in the form of the solid. Then you've got the reversible arrows showing that the reaction can go both forwards and backwards. Now, a lot of you will make the mistake of coming up with a new compound. Please note that this, even if it's an equation, this is not there's no new compound that is being formed. This is just a physical change. So physical change, it's just from one state to another. So we say at BC, we had at -5 degrees Celsius, the solid, it was a solid. And then at BC we say it is a liquid. We've got an equilibrium of X liquid, okay? The answer we have to write just X, the compound is the X, it's still the same compound, but the state of matter has changed because it is now a liquid. So we say there's an equilibrium at point BC. Okay, part 2. What is the significance of temperature T? Temperature T is simply the melting point. Okay, it's the melting point. However, do remind ourselves that the melting point and the freezing point are the same for a substance. So the answer can either be the melting point or the freezing point. Part 3. What is the physical state of compound X in the region EF? EF. So in the region BC, we've seen that the solid melted. So now CD, it's at the liquid phase. And then we see DE, the liquid will have boiled. So now at EF, it will be in the gaseous state. Okay, it will have been a gas now. In the last part, what will be the difference in the region BC if an impure sample of X had been used? Reminder that when an impure sample is used, it will not boil at a specific temperature. It will boil or it will melt over a range of temperature. Therefore, BC, line BC, instead of being a straight horizontal line, it may be a slope. Okay, it will be a slope because it won't be a specific temperature. Okay, so let us conclude the lesson. We went over the different changes of states. We found out that melting was the change of state from solid to liquid. Freezing was change of state from liquid to solid. Condensation, change of state from gas to liquid. Boiling, from liquid to gas. And sublimation, directly from solid to gas, or the reverse, from gas to solid. Okay, we've seen that there is a difference between evaporation and boiling. Evaporation happens only at the surface of the liquid, whereas boiling will happen within or throughout the liquid. And we've seen that there are the heating curves which shows the changes in temperature as we add heat to a substance. And we'll see that the plateaus, the plateaus show the changes of states, whereby we start with the melting, and the second plateau will be the boiling. So thank you for listening. Hope you have understood the concept. Stay home, stay safe. Goodbye.